Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve all the back questions from Airborne Weather Radar chapter from the book called Ground Studies for Pilots by R.B. Underdown. So let's start with question number 1. Why is a wavelength of 3 cm used for an airborne weather radar? So to allow the antenna to fit in the nose of aircraft, to receive reflections from large water drops, to receive reflections from small as well as large clouds, to keep the weight of airborne equipment to a practical level. So the correct option here is option Charlie. Now a 3 centimeter wavelength will enable reflections from large water droplets. This large water droplets may be situated in a small cloud or a large cloud, in a cumulus cloud, a cumulonimbus cloud. So the most appropriate answer here will be option number Charlie. Okay, to receive reflections, from small as well as large clouds. Next, which of the following contour indications on airborne weather radar would most likely indicate turbulence? Now remember, turbulence is most likely to be encountered, heaviest or dangerous turbulence, when the color shades that you observe on your airborne weather radar screen change from yellow to green to red, like that. So the correct option here will be colors changing very rapidly with distance. For example, let's say this is your airborne weather radar screen. On this radar screen, there is a region full of red color. Now red color denotes reflections received from very intense or very strong reflections, strong returns, and this represent a cloud with many large raindrops of water. Okay, raindrops. Next, a color representing yellow and then green. Okay, yellow and green. Yellow means reflections or returns which are medium, and green means very light or very safe returns, light or no returns. So red stands for strong returns. Remember this. Yellow stands for medium returns. Green stands for light returns or no return at all. Light or no return. Light no returns can also be represented by black color. But as of now, remember these three colors: red, yellow, and green. Now the region or the area where yellow and green are adjacent to each other. Okay, yellow and green are adjacent to each other. That transitional area, that area which is the transition from green color zone to a yellow color zone, that particular region, that transitional zone, like we have in meteorology fronts. Fronts are nothing but the boundaries between two contrasting air masses, cold and warm. So the boundary between them is where you will find wind shear, right, and bad weather. Okay, change in wind direction, wind speed, bad weather, etc. Similarly here, the transitional zone between green and yellow is where you will encounter maximum turbulence. Okay, so remember the correct option is option delta. Colors changing very rapidly with distance. This is called color gradient. We can call it gradient or rainfall gradient. That means the region where there is green color, here you are going to get light rainfall, okay, or returns which are light, not that dangerous. And the region where there is yellow color, you are getting medium returns, meaning that means in this area the rainfall will be much more intense than the area which is green color area. So when you are transitioning or flying from one area to a completely different area, you are going to expect some turbulence because you are transitioning into a completely different atmospheric condition. So that is the case. Next, what is the wavelength of a typical airborne weather radar? Remember, wavelength of a typical airborne weather radar is 3 centimeter. The frequency is 9.375 gigahertz. Okay, and the frequency band is called super high frequency band. Now, wavelength 3 centimeter. Here the option is 30 centimeter, 10 centimeter. So the option should have been 3 centimeter, not 30 centimeter. But 3 centimeter can also be represented or written as 30 millimeter. So the next right answer is option Bravo, 30 millimeter. Next. Question 4. What is the normal maximum range of an airborne weather radar on IFIS? What is IFIS? IFIS is nothing but electronic flight information screen. Electronic flight information screen, right? So on electronic flight information screen, maximum range is 300 nautical miles. And in older systems where there was no electronic flight information screen but normal old displays, in that case the maximum range on those particular old kind of displays will be one old displays I'm writing here. The maximum range will be equal to 150 nautical mile, half of 300. So remember, for IFIS it is 300, which is a new technology, and for old technology screens it will be 150 nautical miles, less than that. Question 5. An airborne weather radar echo at 30 nautical mile when the beam is level with aircraft is lost when center of the beam is tilted upwards at an angle of 2 degrees. How high above aircraft is the top of the cloud? So use the direct formula. Top of the cloud will be equal to tilt minus beam width divided by 2 into range into 100. So what is tilt? Tilt is 2 degree upwards. 2 degree upwards. What is beam width? So beam width is not given to us. So when the beam is level with aircraft is lost when the center of the beam is tilted upwards. So when beam width is not given to you use the standard value, which is 3 degree. Okay, beam width of an airborne weather radar is normally between 3 degree and 5 degree. We will try using 3 degree here. Into range. Range is 30 into 100. So 2 minus 1.5. 2 minus 1.5 into 3000. So 2 minus 1.5 is zero point 0.5 into 3000. That is equal to 1500 feet. So that means the top of this cloud is 1500 feet above your aircraft altitude or above your aircraft flight level. So that means the final answer is the top of the cloud, the top of the cloud is 1500 feet above aircraft, above aircraft. Simple. Next. Looking at airborne weather radar returns on an IFIS screen, where is turbulence most likely? Just now I mentioned turbulence will be most likely where the color gradient or the area where you will find change in colors rapidly. Green, yellow, red, very rapid change of colors. So where the color changes rapidly, yes. Where hook shapes echoes are seen, yes. Turbulence cannot be detected. So correct answer is option Charlie. Both A and B and right. So A is right with respect to colors, the change in colors over a particular small distance. And Bravo tells you the shape of the returns. Now many a times you will be able to spot a peculiar shapes on your airborne weather radar screen. So the shapes are any shape which is a hook shape like this, any shape which has edges, which has rough edges like this. Okay, so remember hook shapes. Okay, any shape with scalloped edges, shapes which are like fingers. This some of these shapes must be at all times avoided. Okay, so remember these shapes. So these shapes, looking at this, this comes with experience. Okay, with experience you will be able to interpret the information given on your screen, weather radar screen. So so color gradient is to be avoided, and hook-shaped echoes are to be avoided as well. Question number 7. Why is the mapping beam sometimes referred to as cosec squared beam? Very important for your ATPL. Now the time of scan depends on the cosecant of angle. Range is found by measuring cosecant angle of the beam. The cosecant angle of the beam is proportional to aircraft speed. Transmitter power is proportional to cosecant of the angle from horizontal. Now it's very important. Now wherever we use airborne weather radar for navigation purposes or for mapping of the ground below aircraft, let's say this is your aircraft, okay? This is your aircraft. There is a ground level below the aircraft, and then this is the mapping beam, okay, which is sent downwards towards the ground. Now any return any return which is close to aircraft will be represented will be represented as a very bright return. Any return which is coming from far away from aircraft, any return which is coming from far away will be represented, या फिर will be shown on the airborne weather radar screen, okay, will be shown as a light return. In reality, this return coming from a target which is much far away from aircraft may be a very important one, and the target and the return which is coming from a target which is close to aircraft, comparatively closer to aircraft, may not be that important significant target, but still the target which is close to aircraft is represented as a very bright target or a very bright representation or a very bright return, but the target which is far away from aircraft, although very important one, is represented as a very light return, very light color or light shade of color. Okay, so just because the target is far away from the aircraft, it is represented as a non-important, unimportant target or a very light return. So in order to establish balance between the colors of all targets, okay, balance, to establish a balance between all the returns, whether these returns are coming from a target close to aircraft or coming from a return or coming from a target which is much far away from aircraft, to establish a balance among all of these returns and to create equal ground, okay, we use we use cosecant squared beam. That means the beam which is going at a much farther distance from aircraft, the transmitter power, the power at which this beam is sent to far distance, okay, far away distance, will be increased. Power will be increased, so that means the return which is coming from a target very much far away from aircraft will be represented in the same manner as the target which is as the return from a target coming from close to the aircraft. Okay, so there will be uh, equal representation. Whether the target is close to aircraft, it will be shown represented on the airborne weather radar screen depending on its severity, whether that target is safe or dangerous. And any target return coming from a target far away from aircraft, it will be represented depending on how dangerous or safe it is. So that is the use of cosecant squared beam. So the correct option is delta. The transmitted power is proportional to cosecant angle from horizontal. Okay, the angle at which the beam is deflected towards the ground. Okay, so cosec of that angle, the power will be adjusted. This is nothing but to create a balance among all the returns coming from close ranges and far away ranges. Nothing else. Question 8. By how much should a long-range jet pilot avoid strong echoes on his airborne weather radar when flying at cruise altitude? Okay. So remember, when you are flying, when you are flying below 20,000 feet, below 20,000 feet, you should avoid strong echoes. You should avoid strong echoes by a distance of 10 nautical miles. Between 20,000 feet and 25,000 feet, you should avoid all strong echoes by 15 nautical miles. 25,000 feet, 30,000 feet, you should avoid all echoes by 20 nautical miles. And above 30,000 feet, any jet transport aircraft flying above 30,000 feet will have to avoid all these airborne weather radar strong echoes or returns by at least or more than 20 nautical miles. So the correct option here will be option delta. We all know that long range jet aircraft will fly at a cruising altitude above 30,000 feet. So the distance by which you have to avoid this airborne weather radar signals or returns will be a minimum 20 miles or more than that. Question number 9. What does swept gain mean in an airborne weather radar? So transmission power increases as range increases. The returns are stronger at large angles. Transmission power increases as cosec of the angle from horizontal. Receiver increases sensitivity with time. So correct option is option delta. Okay. Swept gain is automatic. It happens automatically and it can also happen manually. What happens is whenever transmitter is sending a radar pulse, okay, to detect a cloud, to detect a large water raindrop of water, right? So water droplets which are close to this radar or close to aircraft will be reflected quite easily and represented on the screen of the cockpit as a very bright return. Okay, but reflections coming from targets which are much far away from the radar, okay, will be may or may not be received at the receiver, okay, properly or sufficiently. That's why in order to establish, again, just like cosmic beam where we have to establish a balance between the colors of returns coming from close targets and returns coming from far away targets, in this case of swept gain, what happens is we are sending the radar pulses that we are sending at much farther distances. They must also be received by the receiver, just like reception happening from any target close to the radar. So in order to establish that level playing ground, the swept gain is used so that receiver increases sensitivity with time. So the radar pulses which are coming from much far away distance will also be received at the receiver successfully, just like any other radar return coming from a short distance. That's it. Simple. Next, question number 10. What is an ISO echo? It is a black indication in the middle of a white radar return, a strong echo showing turbulence, a green indication on an IFIS display, a strange shaped return on a screen of airborne weather radar. So ISO echo is nothing but a black indication in the middle of a white radar return. Okay, black indication in the middle of a white radar return. Next, question 11. Flying at flight level 270, an airborne weather radar return at 40 nautical miles is identifiable when the center of the beam is tilted between plus 1 degree and minus 1 degree. Okay, minus sign is missing, and minus 6 degree. What is the height of the base of the cloud and top of the cloud? We have to find both base and top of the cloud. So let's first find top of the cloud using the formula tilt minus beam width divided by 2 into range into 100. Okay. Now here the tilt for finding the top of the cloud is plus minus 1 degree. Plus minus 1 degree means 0 degree. So let's substitute 0 degree here. Beam width is given to you, beam width is not given to you. And whenever beam width is not given to you, use standard beam width value of 3 degree. So 3 degree divided by 2, range is 40 nautical miles into 100. So minus 1.5 into 4,000. So minus 1.5 thousand is minus 6,000. That means your final answer will be the top of the cloud is 6,000 feet below aircraft. Now what is the height of aircraft? Aircraft is at flight level 270. So top of the cloud will be 27,000 feet where your aircraft is situated minus 6,000, which is 21,000. Okay. So top of the cloud will be situated at 21,000 feet. So let's draw this. Here is your aircraft. Aircraft is at 27,000 feet. There is a cloud. The top of the cloud is at 21,000 feet. Now we have to find the base of the cloud. Again, we will use the same formula. Base of the cloud equals to tilt minus beam width divided by 2 into range into 100. So tilt, downward tilt is minus 6 degree. So minus 6 minus 3 divided by 2, range is 40 into 100. So minus 6 minus 1.5 into 4,000. Erase this 6 minus, just write 6. Okay, so 6 minus 1.5 is 4.5 into 4,000, which is equals to 18,000 feet. That means the base of the cloud will be 18,000 feet below the aircraft altitude. Okay, base of the cloud is 18,000 feet below aircraft altitude. Aircraft is at 27,000 feet. Base of the cloud will be 27,000 feet minus 18,000 feet, that is equal to 9,000 feet. 9,000 feet. Okay, that means the base of the cloud is at 9,000. 18,000 feet below aircraft. And top of the cloud is at 21,000, which is 6,000 below aircraft. This is how you do it. Next. Over here, true heading of aircraft is 270. 27. True heading of aircraft is 270. There is an island which is 150 nautical miles away. Okay. This concludes our lecture. I hope you have understood all the questions from this particular chapter, from this particular ground studies for pilots book. I have taken these questions from this particular book for extra practice. If you have any doubts, any questions, do let me know in the comment box. I will happily resolve them. I request you all to subscribe to this channel, like this video lecture, and share this video with all your friends. Thank you for your time. Don't miss my next lecture in which I will be solving all airborne weather radar questions from Keith Williams. All the best.